Still, others persevered. Around 1783, an Italian called Luigi Galvani was poking around with a metal scalpel one day. Oh, it's all right, it's only frog's legs. I guess he was fond of frogs. When suddenly, the leg lying on a metal plate jerked. Galvanized by this discovery, Galvani announced animals made electricity. In 1800, another Italian, with the electrical name of Volta, got it right. Volta saw that the electricity came from reaction between Galvani's scalpel and the metal in the plate under the frog. So he built a pile of differing metal plates and got electricity, called it his pile. Well, now our loonies had Volta's pile to give them constant electricity. There was no stopping them. Various attempts were made to send current down wires which would cause pith balls to swing. Each wire and ball represented a letter, and the message could be read off the other end. They actually got it going between Madrid and a town 26 miles away. Then came a really zany one. If you put an electrified wire into water, it makes bubbles. So yes, you've guessed it. A German doctor used the bubbles to send messages. Things ended in typical chaos when somebody tried electricity with gunpowder. By the beginning of the 19th century, things became very much more purposeful than that. And although an awful lot of innovation and change comes about by accident, by mistake, cheating, fooling around, it sometimes happens because people find something out that sets them thinking. And that's what happened in this case. In 1820, a rather dull Dane called Ørsted was teaching his students that an electric current going down a wire shouldn't have any effect whatsoever on a compass needle. When, to his utter chagrin, it did. Well, no fool he, Ørsted immediately made it known that if an electric current going down a wire caused a compass needle to swing, it had to be generating a magnetic field and moving the needle. Poor old Ørsted. I mean, who's ever heard of him? Michelangelo, yes. Ørsted? And yet, the fact that an electric current generates a magnetic field is fundamental to the way the world is run today. I mean, take just one thing that happened because of Ørsted. If you wind a live wire round and round a bit of iron, the magnetic field generated by the current causes the iron to become a magnet, an electromagnet. Now, somebody did that in England in 1825. In 1857, a German took a tuning fork and put it next to an electromagnet, turned it on and off, turned the magnetic field on and off, and caused the tuning fork to vibrate. And then, in 1870, a Frenchman living in America took a diaphragm, put a bristle on the end of it, and then yelled into the diaphragm to make it vibrate. And the bristle jiggled up and down and made a pattern on smoked glass. And the pattern was always the same for the same word. Now, I say all this because the brilliant invention that came out of it, and it was a brilliant invention, was really no more than putting all those bits and pieces together. Like this. You yell into that cone. That causes a metal diaphragm here to vibrate. Now, that metal diaphragm is within this magnetic field, and as it vibrates, it kind of drains it, causing the current in the live wire to fluctuate. This fluctuating current fluctuates along a wire until it reaches an identical setup, where because it's a fluctuating current, it makes a fluctuating magnetic field. And that causes another metal diaphragm to vibrate in exactly the same pattern as the first one. And when it does that, it makes a noise in that cone. So, what you yell in here comes out there. Now, that basic idea occurred to two men at the same time. Only one of them, a Scotsman living in Boston in 1875, teaching deaf mutes, got to the patent office 2 hours ahead of the other fella. And that 2-hour difference is why we say that the telephone was invented by Alexander Graham Bell. The telephone was only one result of Ørsted's accident with that compass needle. Another is our ability to scan the universe with this giant antenna, suspended above a reflector that covers an entire valley 500 feet below. Another is the way this program has been broadcast, on radio waves, or the way we defend ourselves against attack from incoming missiles with radar, because both radio and radar work by sending out and receiving electromagnetic signals. And it was Ørsted who found that connection between electricity and magnetism. It's ironic that this program should have begun with war, with the bomb in the suitcase and the stirrup, remember? And end with the means of preventing war through the use of telecommunications, perhaps to bring the peoples of the world closer together into one community. And finally, perhaps, to discover that we are part of an infinitely larger community on the day when a transmitter-receiver like this one in Arecibo in Puerto Rico makes contact with the galactic civilizations that are almost certainly out there in space. Meanwhile, as we wait for the great encounter, at a more down-to-earth level, what will the capacity that telecommunications provides of organizing people do to us?